In this lesson, we're going to learn how to solve rational equations. Now, before we solve rational equations, remember in the previous lessons, we saw how to solve quadratic inequalities and higher order polynomial inequalities. So remember this is a polynomial inequality, but in particular, it's quadratic, and we saw how to do that. So when we solve a rational inequality, the process for the most part is the same idea, except that you're going to notice that in a rational inequality, when we do a rational inequality, you're not only going to be looking at the zeros of what makes the expression equal to 0, but in a rational inequality, you're going to notice that we have to do something with the denominator. Okay, so then the problems that we're going to look at, we're going to be solving rational inequalities that look like this. So it'll be a polynomial divided by another polynomial, and it will be an inequality. So it could be something like less than 0, or less than or equal to 0, or greater than 0, or greater than or equal to 0. But in particular, you're going to notice that the way that these are going to look for us is that you're going to have a polynomial divided by a polynomial. All right, so for example, so the directions will say something as solve each solve each rational inequality. Solve each rational inequality. All right, now, for example, let's look at the first one. So let's say the first one was this. We had x plus 4 divided by x minus 1 is greater than 0. All right, so this right here is of this form. And notice that the numerator is a polynomial and the denominator is a polynomial. In fact, the numerator is a linear expression, so is the denominator. All right, so let's look at the steps on how we're going to do this. So these are the steps to solving a rational inequality algebraically. First thing you want to do is to factor both the numerator and the denominator. And so if you notice that the numerator is x plus 4 and the denominator is x minus 4, you can't factor that. You cannot factor that any further. All right, so step number 1 has already been done for us. Now step number 2, you want to find the zeros. And notice step number 2, step 2 and 3. So step 2 says find the zeros, and step 3 says find the values of the variables that make the denominator 0. And some textbooks will call this the undefined points. So where is this expression equal to 0, and where is this expression undefined? All right, so to find the zeros, so what makes this 0? And let me go ahead and write this out. So I'm asking you this question. This is what I'm asking you. I'm asking you, where is x plus 4 divided by x minus 1 equal to 0? That's what I'm asking when I'm asking you to find the zeros. So find the zeros of this expression. Well, notice that I can multiply both sides by x minus 1, right? And so the x minus 1's divide out, so you get x plus 4 is equal to, and then 0 times x minus 1 is 0. And so notice you have this linear equation, and so you get x to be negative 4. So that's your 0. So I want you to notice, though, and that's why it says this. Find the zeros, and it's going to be from the numerator. Because whenever you set a rational expression equal to 0, like this right here, equal to 0, the part that you end up with is that the numerator has to be 0. That's the only way you can get this rational expression to be equal to 0 is when the numerator is 0. So that's why it says set the numerator equal to 0. All right, so the zeros are, and we'll go ahead and write it out. So the zeros are, so this is what you did. So you said x plus 4 is equal to 0, so x equal negative 4. So there's your 0. 0 is x equal negative 4. All right, now the undefined points, so let's talk about that, the undefined points. Undefined points. So a rational expression, I'm going to go ahead and write this out right here. So a rational expression, x plus 4 divided by x minus 1, is undefined when the denominator is 0. Denominator is 0. So for example, 6 divided by 0 is undefined, right? You cannot divide by 0. So when you're finding the undefined points, which is what we're doing here, when finding the undefined points, all you do is set the denominator equal to 0. Where is this denominator equal to 0? All right, so to find the undefined points, we're going to say x minus 1 equal to 0. So x has to equal 1. So there is my undefined point. So my 0 is at -4, and my undefined point is when x is 1. Okay? All right, so that is steps 2 and 3. So let's kind of review this. Step 1, to find the zeros, you just set the numerator equal to 0. To find where the undefined points are, you set the denominator equal to 0. Okay? All right, now the next thing you're going to do is you're going to put these zeros, undefined points, on the number line. So let's put that in a number line. And the rest is very simple. The rest of this process is very simple because it imitates the process that you did for the polynomial inequalities. So we're going to put the zeros and the undefined points on the number line. Make sure you put them in order. So -4 and 1. So I'm going to put -4 first and 1 next. And I want you to notice something. These undefined points and these zeros divide the number line into 3 intervals. This interval from -infinity to -4, the interval from -4 to 1, and the interval from 1 to infinity. Okay? And so you're trying to find out which of those intervals will make this inequality a true statement. Okay? So what are the solutions? So what are the solutions to this inequality? Okay, so remember when you did the polynomial inequalities, the next thing you did was your test points? Same thing. So step number 5 is you're going to test each interval to find the sign of the rational expression in each interval. Okay? So let's do some test points. So give me a test point between -infinity and -4. So we're going to say -5. And remember as before, it's always easiest to try and use a test point that's an integer. You won't always, but it's always easiest to do that. A test point between -4 and 1 is 0. 0 is a nice one to use. You could use -3. You could use a decimal if you want to, like 0.5. All right, any real number between -4 and 1. And then you want to pick a test point between 1 and that's greater than 1. And so let's say 2. Okay? So these are my test points. Now, just like you did with the polynomial inequalities, the next thing is to determine what is the sign of this interval. What's the sign of this interval? Okay? All right, so notice you want this expression to be greater than 0. Let me go ahead and write it out right here so I can write something else. So you want this expression right here, you want that expression to be greater than 0. Remember, greater than 0, a number that's greater than 0, like 1, 2, 2.7, 3, things like that, are positive numbers. So you want this to be a positive number. So my solutions to this inequality will be any value of x that makes this rational expression positive. So I'm looking for positive intervals here. Okay? All right, so let's do the test point, -5. And remember what we did before, we take x equal -5 and we substitute it wherever we see the variable x. So I get -5 plus 4 divided by -5 minus 1. And then we look at the sign. Well, -5 plus 4 is a negative number. Divided by -5 and a -1 is a -6. That's a negative number. Well, negative divided by negative is a positive. So when x is -5, this expression is a positive number. In fact, no matter what test point you used in here, if you chose -10, -6.8, that expression will be positive. So next question is this: is this interval from -infinity to -4 going to be a solution? And the answer is yes, because any number from -infinity to -4 will make this rational expression positive, and that's what I want. So I'm going to put a little check there to remind me that's going to be an interval that's going to be one of my solutions. Then we go to the next test point, 0, and where we see the variable x, I substitute 0. So I get 0 plus 4 divided by 0 minus 1. Well, 0 plus 4 is a positive number, divided by 0 minus 1 is a negative number, it's -1. A positive divided by negative is a negative. So any real number between -4 and 1, any real number between -4 and 1 will make this rational expression negative. So, but that's not what I want. I want this rational expression to be greater than 0, which means positive. So I'm going to put a little x there to remind me not to use it. And then the next test point's 2, and so do the same thing. So you're going to say 2 plus 4 divided by 2 minus 1. 2 plus 4 is 6, that's a positive number, divided by 2 minus 1 is a positive number, it's positive 1. A positive divided by positive is a positive. And so notice that any real number greater than 1 is a solution because any number greater than 1 will make this expression positive, and that's what I want. So I'm going to put a little check there. Okay, now let's talk about these zeros and undefined points. Okay, now listen carefully. The undefined points are never going to be a solution. Okay? The undefined points will never be a solution because it makes the expression undefined. That's how you found it. So let me explain that a little bit better. So you have x plus 4 divided by x minus 1 is greater than 0. So my undefined point is 1, right? So if I substitute 1 in here, so when x is 1, I get 1 plus 4 is 5, 1 plus 4, divided by 1 minus 1, and the question is this greater than 0? That's the question. Well, 1 plus 4 is 5, 1 minus 1 is 0, and so if you're asking is that greater than 0, the answer is no, because this part here is undefined. That's undefined, right? Because you cannot divide by 0. So when x is equal to 1, this is not a solution. So let me write this. X equal 1 is not a solution. And it's not a solution because it makes this rational expression undefined. All right? And so therefore what I would do, and you should do this too, you need to do this, is for the undefined points, whenever you put them on the number line, whenever you put the undefined points on the number line, put an open circle right away. Put an open circle right away. Remember, the open circle means you cannot include it. It's not a solution. All right, now let's talk about the 0. All right, I'm going to ask you this, and I'm going to write it out, and then after that point, you're going to know what to do with the zeros. Okay, so the 0 in this case is x equal -4. So let's go ahead and rewrite this over again. X plus 4 divided by x minus 1 is greater than 0. So when I substitute -4 in here, here's what I get. -4 plus 4 divided by -4 minus 1, and the question is this greater than 0? Well, -4 plus 4 is 0, right? And then in the denominator, -4 minus 1 is a -5. And so the question is this greater than 0? Well, 0 divided by -5 is 0. Now, be careful. Is 0 greater than 0? And the answer is no. 0 is not greater than 0. 0 equals 0, right? So what that means is that x equal -4 is not a solution. X equal -4 is not a solution. Now, here's the quickest way to determine whether a 0 is going to be open or closed. Remember, open means it's not a solution. Closed means it is a solution. Is there an equal sign? Because remember, when I went here, I asked you, is 0 greater than 0? The answer is no. So x equal negative 4 is not a solution. Remember, 0 is equal to 0. That's true. Or 0 is greater than or equal to 0. That's also a true statement, right? So whenever there's no equal sign, then it's not a solution. If there is an equal sign, like you see here, then it is a solution. So, undefined points, always going to be open circle. It's not a solution. Zeros depends. A 0 is a solution. It depends on if there is an equal sign here or not. Since there's no equal sign, it is going to be an open circle. Okay? All right, and so you're almost done. And so the next step, step number 6, is to write the solution of the inequality using interval notation. Now, before we go on, I want you to note from our discussion, the undefined points will always have an open interval, while the intervals of the zeros will depend on the inequality sign. So it would be, does it have an equal to symbol or not? So since there's no equal to symbol here, it's going to be open circle. Okay? All right, so here's your answer. Very simple, isn't it? The very simple process. So your interval, so your solution in interval notation is negative infinity to negative 4 open circle. I'm sorry, parentheses because of the open circle. Union, and then parentheses 1, comma, all the way to infinity. And that's all you do. All right? So there's the work, and there's your answer. All right, so let's go to number 2. So it's not a difficult process. It's very simple, and one of the reasons very simple is because of the previous lesson. So the previous lesson, when you solve quadratic inequalities or higher order inequalities, higher order polynomial inequalities, the process is very similar. Okay, except the only difference now is that let me go ahead and do this. The only difference now is that you have to look for the undefined points. All right, the undefined points. Since it's a rational expression, you got to determine what makes the denominator equal to 0. Okay. All right. So let's go to number 2. So number 2, we have this for number 2. All right. We have x minus 3. I'm sorry, x minus 5 divided by x minus 3 is less than or equal to 0. All right. And so notice you have 0 on that side. That's important, just like it was with the higher order polynomial inequalities. 0 on that side. All right, now remember, the first thing you got to do is make sure that your numerator and denominator are factored, and they are. They're factored. You can't factor any further, so they're prime. Then the next thing, remember, is this: find your zeros and find the undefined points. So in a rational expression, this is equal to 0 when the numerator is 0. So you're going to set the numerator equal to 0. So you get x equal 5. Now what that means is that your 0 is x equal 5. Okay? Now you're going to find the undefined points. The undefined point. So a rational expression is undefined when the denominator is equal to 0. So you set the denominator equal to 0. And so you get x to be 3. So my undefined point is x equal 3. Okay? Once you get to that point, then the rest is easy. The rest is easy. So let's put this on the number line. We're going to put the 0 on the number line and the undefined point on the number line. Make sure you put it in order. So 3 and 5. And just as before, these points here, the 0 and the undefined point, divide the number line into 3 intervals. And so you have to determine which of those intervals will be solutions to this inequality. And when I look at that inequality, I'm going to write it over. When I look at an inequality, I'm trying to find values of x that will make this expression less than 0 or equal to 0. Okay? Well, remember, less than 0 means negative, and then in this case, since there's equal sign, it'll be anything that makes this negative or 0. All right? Okay. So the next thing is to find test points. So a test point between negative infinity and 3, let's say 5. A test point between, not 5, I'm sorry, let's say 0, excuse me. A test point between 3 and 5, let's use 4. Remember, it's always easiest, that's a 0 here. It's always easiest to use a test point that's an integer. You won't always be able to. So you would need to use a decimal or fraction at that point. All right, and so a test point that's greater than 5, let's say 6. All right, so I have my test points, and now what I'm going to do is I'm going to take each of those test points, I'm going to test those intervals, and I want to determine which of those intervals will make this expression negative. Okay, negative. All right, and so let's use 0. Let's do 0 first. So go back where we see the variable x, you substitute 0. So I get 0 minus 5 divided by 0 minus 3. So you're looking at those factors. 0 minus 5 is a negative number. That's negative 5. 0 minus 3 is a negative number, right? Negative 3. A negative divided by negative is a positive. So question becomes, will the interval from negative infinity to 3, okay, will the interval from negative infinity to 3 be a solution to this inequality? And the answer is no, because you want this expression right here to be less than 0, negative, or 0. This is positive. Okay? All right, so I'm going to put a little x there to remind me that that's not going to be a solution. Then we go to 4. So do the same thing. 4 minus 5 divided by 4 minus 3. Well, 4 minus 5 is a negative number, negative 1. 4 minus 3 is a positive number. A negative divided by a positive is a negative. So what that means is that any real number between 3 and 5 will make this expression a negative number. And that's something I want, less than 0, negative. So I'll put a little check there. Then let's go to 6. So we have 6 minus 5 divided by 6 minus 3. Well, 6 subtract 5 is a positive number. 6 subtract 3 is a positive number. A positive divided by a positive is a positive. So what that means is that any real number that's greater than 5 will make this inequality symbol this rational expression a positive number. But that's not what I want, because I want this rational expression to be less than 0, negative, or equal to 0. Okay. Now, let's talk about the zeros and the undefined points. So I'm going to ask you this question. For the undefined point 3, are you going to put a closed circle or an open circle? Based on our discussion before, you're going to remember that 3, when x is 3, x equals 3 makes this rational expression undefined. So that means that this cannot ever be a solution, because it makes it undefined. So you're always going to have open circle on the undefined point. It is the 0 that you need to be careful with, because the 0 can be open or closed. The undefined point is always open. So for the 0, remember, you're going to ask yourself, is there an equal sign or not? So remember a while ago I put negative or 0. So you want this to be 0. Well, this is 0 when x is 5, right? So that's going to be a closed circle. And so therefore, your answer is just this interval here. So your solution in interval notation will be parentheses 3, comma 5 with a bracket. And that's how simple this is. It is not difficult at all. Not difficult at all. Okay, so let's look at number 3. Number 3. All right, number 3, we have this. We have x plus 1 divided by x squared minus 4 is greater than or equal to 0. Okay, so x plus 1 divided by x squared minus 4 is greater than or equal to 0. All right, so remember, step number 1 is to factor both numerator and the denominator if possible. So the numerator, I cannot factor any further, but the denominator is the difference of two squares. So let's go ahead and factor that. So I'm going to rewrite this over. I got x plus 1 divided by x minus 2 times x plus 2 is greater than or equal to 0. Okay? All right, so first thing is to factor numerator and denominator. Now we're going to find two things. We're going to find the zeros, and we're going to find the undefined points. So this rational expression is 0 when the numerator is 0. So all I do is set the numerator equal to 0. And so I get x to be negative 1. So there's my 0. So my 0 is x equal negative 1. Okay? Now let's do the undefined points. So my undefined points, that's where you set the denominator equal to 0. But notice there are two factors, right? Two factors, so you're going to do both of them. So you're going to say, let me do that here. You're going to say x minus 2 equals 0, x plus 2 equals 0. So x minus 2 is equal to 0 and x is 2. X plus 2 is equal to 0 and x is negative 2. So you have two undefined points. So your undefined points are x equal 2, x equal negative 2. All right? So in the previous problem, you had 1, 0, one undefined point. All right? And then those two numbers divided the number line into 1, 2, 3 intervals. In this one, you have 1, 0, and two undefined points. So when you put that on the number line, and it makes you put them in order. So you have negative 2 first, then negative 1, and then 2. Okay? So those three numbers divide the number line into 4 intervals. Negative infinity to negative 2, negative 2 to negative 1, negative 1 to 2, and then 2 to infinity. Okay? All right, now I'm going to rewrite this over because I need to say this. So x plus 1 divided by x minus 2 times x plus 2 is greater than or equal to 0. So I'm trying to find the values of x that will make this rational expression greater than 0 or equal to 0. So greater than 0 means positive. Equal to 0 means 0, right? So positive or 0. So I got to find out which one of those are positives. Okay, so now we're going to do test points. So give me a test point between negative infinity and negative 2. So any real number between negative infinity and negative 2. So let's say negative 4. All right, now notice there is no integer between negative 2 and negative 1, so we're going to have to resort to either a fraction or a decimal. It's always easiest to use a decimal. So let's say negative 1.5. Okay? And then a test point between negative 1 and 2, we can say 0. And then a test point from 2 to infinity, we can say 4, let's say. All right, and so now all I need to do is take these test points and substitute back into my rational expression, but let's go ahead and use the factor part. All right, so let's go ahead and do that. So where we see the variable x, I'm going to substitute these test points. So let's start with negative 4. So I have negative 4 plus 1 divided by, now the denominator, negative 4 minus 2 times negative 4 plus 2. Okay? Now let's go to the numerator. Negative 4 plus 1 is a negative number. Divided by, negative 4 and a negative 2 is a negative number. That's negative 6, right? And then times, negative 4 plus 2 is also a negative number. That's negative 2. All right, now look at what we have. The numerator is negative. Y'all agree? And put equal negative. The denominator, a negative times a negative, is a positive. And now this kind of looks like the previous one. A negative divided by a positive is a negative. So this interval is negative. So what that means is that any real number between negative infinity up to negative 2 will make this rational expression negative. Is that something I want? The answer is no. So I'm going to put a little x there. All right, then we go to negative 1.5. Do the same thing. Now, whenever you have a bunch of these more than 2 zeros and undefined points, like we have here, this part here, all that work becomes kind of messy. So try and be neat around this area as much as possible, because you're going to be putting a lot of stuff there. So let's get to negative 1.5. So I receive the variable x, I'm substituting negative 1.5. So I have negative 1.5 plus 1 divided by negative 1.5 minus 2 times negative 1.5 plus 2, right? Wherever you see the variable x, substitute your test point. Negative 1.5 plus 1 is a negative number. All right, so it's becoming a little bit messy, right? Because negative 1.5 plus 1 is a negative 1/2, right? Negative 1.5 and negative 2 is also a negative number. And then negative 1.5 plus 2 is a positive number. That's positive 1/2. So I have a negative in the numerator, right? Negative in the numerator. And in the denominator, a negative times a positive is a negative. And a negative divided by negative, and I don't have enough room here, so I'm going to put it right here. A negative divided by negative is a positive. So what that means is that any real number between negative 2 and negative 1 will make this rational expression positive, and that is something I want. So I'm going to put a little check there, because that's what I want. Then we go to 0. We go to 0 now. Do the same thing. Where we see the variable x, I substitute 0. So I get 0 plus 1 divided by 0 minus 2 times 0 plus 2. It's very simple, not difficult at all. 0 plus 1 is positive. I'm running out of room, so I'm going to have to do that down here. I apologize. Is positive. The denominator, 0 minus 2 is a negative number. That's negative 2. And then the other factor in the denominator, 0 plus 2 is positive. The numerator is positive. The denominator, a negative times a positive is a negative, and that is equal to a negative number, right? So that's negative. So what that means is that any real number between negative 1 and 2 will make this rational expression negative. Is that something I want? No. I want that rational expression to be positive or 0. All right, so I'm going to put an X there to indicate that that's not going to be a solution. Then we go to 4. Do the same thing. Now I don't have enough room here, so I'm going to have to do that here. Then we go to 4. Do the same thing. You're going to say 4 plus 1 divided by 4 minus 2 times 4 plus 2. Well, 4 plus 1 is positive, right? It's positive 5. 4 minus 2 is a positive 2, so I'm going to put positive there. And the other factor in the denominator is 4 plus 2, which is 6, which is positive. So the numerator is positive. The denominator, positive times a positive is a positive. And we know that a positive divided by a positive is a positive number. And so what that means is that any real number greater than 2 will make this rational expression positive, which is something I want. Okay, so I did my intervals. I know which intervals are going to be my solutions. Now I've got to look at the zeros on undefined points. I got to put whether they're open circles or closed circles. Well, we all know that for the undefined points, they will always be not a solution. So we're going to put an open circle. So an open circle here and an open circle here. Now we look at the 0. So remember, the 0 will be a solution if you see an equal sign. So negative 1 will make, see negative 1, when I substitute negative 1 plus 1 is 0. 0 divided by whatever the number this is still 0. So 0 equals 0. So if you see an equal sign, then that 0 is going to be a solution, so you can put a closed circle. And we're almost done. So let's go ahead and write the solution. So my solution, your solution, in interval notation will be from parentheses, negative 2, comma, all the way to negative 1 with a bracket, union, and then the next one you'll say parentheses 2, all the way to infinity with parentheses. And remember, parentheses and infinity and negative infinity, you always going to use parentheses. And that's it. So that is the solution to this problem. Now, just remember, when you get to this point, it can get pretty messy. So try and do the best you can with making this as neat as possible. All right. So that was number 3. Okay. So I am going to do the other 2 problems in the next video. So problem number 4. In problem number 4, we'll do another one where the polynomial is quadratic, just like in the denominator. This is quadratic, so we'll do another one like that in the next problem, and that's going to be in the next video. All right, so that's going to take care of these 3 problems on this part of the lesson.